In this video, we will show the function fz defined by image z by mod z if z is not equal to 0 and 0 if z is equal to 0 is not continuous at z is equal to 0. Now for continuity, we need to show that limit z goes to 0, fz is equal to f of 0. Now see that we have f of 0 is equal to 0. Therefore, in order to show this function is not continuous at z is equal to 0, we need to show that this limit is not equal to 0. Now, limit z tends to 0, fz is equal to limit z tends to 0, image z divided by mod z. Now we will write z as x plus iy. So x plus iy tends to 0, and we know that image z is equal to y and mod z is equal to square root of x square plus y square. Now we will compute this limit along the lines y is equal to mx. Putting this value here, this will be equal to limit x plus I times mx tends to 0, y is equal to mx, so we have mx in the numerator, and in the denominator we have square root of x square plus m square x square. Now this limit is same as limit 1 plus I times x tends to 0, mx divided by x times square root of 1 plus m square. This is again same as limit x tends to 0, m divided by square root of 1 plus m square. Now this is independent of x, so this is limit is equal to m divided by square root of 1 plus m square. As this limit depends on the value m, we get different limits for different values of m. This implies that limit z tends to 0, fz does not exist, which further implies that fz is not continuous at z is equal to 0. And this completes our proof. Please like, share and subscribe our channel. Thanks for watching.